Okay, this begins our chapter 12, our final chapter for 3D objects. We need to talk about what 3D objects are first before we can get into some examples with them and some applications. So first of all, polyhedron. It's a solid closed 3D shape bounded by polygons. Remember, a polygon is a two-dimensional object that is made up of straight lines. So if you look at these first couple of examples, it says determine whether it is a polyhedron. If it is, name it. So remember, it has to be solid, closed, and 3D, made by polygons. The first one, it is a polyhedron because it's made by polygons. You can see the sides are all triangles and the bottom is a heptagon. So we can say, yes, this is a polyhedron because it's made up of polygons and it's closed, and we can name it as a heptagonal pyramid. It has one base and the sides are all triangles. This is not a polyhedron, this is a cylinder because of the curved sides. Anytime that there is a curve, it will not be a polygon. And the third one, this is a polyhedron because it is made up of rectangles on the side and a nonagon on each of the bases. So this is a polyhedron because it's made up of polygons, and we can name it as a prism because it has congruent bases and the sides are made of rectangles. I will review the difference between a prism and a pyramid using 3D objects that you guys can actually see in class, but I do want you to at least have an idea. Okay, faces. The faces are the polygons that make up the polyhedron. So if you look at that first example, the faces are the triangles that make up the side and the heptagon that makes up the bottom. That's considered a face, a polygon. The edge is a line that joins two faces. So this would be an edge. This line right here, from here to here, would be an edge. A vertex is where two edges meet. So if this edge and this edge meet at this point, if you had this in front of you, it would be the pointy edges or the pointy points. The base, there's two different ideas where bases are. If it's a pyramid, it's a singular unique face. So on this pyramid, this heptagon that makes up the bottom of this pyramid is the base. So that's the only way you can really have this sitting. With a prism, this is a nonagonal prism, there are two bases. This base here, and then there's one base on the opposite side that is parallel. And again, I will show you pictures of these in class. Those are the two bases. So a prism will have two bases, whereas a pyramid will have one. We need to look at the number of sides, the vertices, the edges, and the faces for these three. Pretty self-explanatory. You just have to think about top and bottom, left and right, and front and back, especially for faces. Vertices, you can usually count them, and same with the edges. So I'm just going to go through so you can take a minute and count them on your own, then double check them with my work. You can pause the video and look at it that way too. A regular polyhedron, all the faces are congruent regular polygons. So we just talked about this in chapter 11 about what a regular polygon is. All the angles are the same and all the sides are the same. So a regular polyhedron has all congruent polygons that are regular on all sides. A convex polyhedron, its surfaces do not intersect. So what we mean by that, if you look at these three examples at the bottom, this is considered concave. So look at our definition, convex, the surfaces do not intersect. Well, this is concave if you think about it having kind of an indent. Do you see how this one kind of indents here? If you think about this polygon and this polygon, if I were to extend them in all directions, they would intersect. So that's why it's considered concave, kind of that indent. This one is considered convex, similar to like a soccer ball. If I were to extend this shape or any of the shapes on the sides, it would continue on in all directions. That direction, this one, and this one. So by continuing in that direction, it would never intersect any of these other polygons and any other part of this polyhedron. So this one is considered convex because there's no indent. This one is concave because, and the way it's drawn, hopefully you can see that it kind of has an indent here. Whereas if I were to continue that triangle, that polygon that makes this up, and this one, they would intersect and they would cross each other. They wouldn't just touch, they would intersect. So hopefully you can see that there's kind of an indent on this one, There's kind of an indent here, whereas those two are concave. This is convex because there would not be any intersections of the polygons that make up that figure. Similarities between a prism and a pyramid. I talked about this a few minutes ago. A pyramid has one base and triangle sides, whereas a prism has two congruent bases and rectangle sides. Going back to the front side, see there's one base on there that I had highlighted a minute ago, and all the sides are triangles. This prism has two congruent bases, and the sides are all these rectangles. This is the sides, and those rectangles go all the way around. You can kind of see them with the dotted lines. A cross section, it's kind of like a slice of a 3D object. So if you look at these, it says describe the cross section. Hopefully they're pretty clear to you. We're taking a pentagonal prism. You can see the two pentagons on either side, and then this is kind of like the slice of it. They're cutting it down the middle, and they want to know what would it look like if I cut it open and looked at it. Well, you would see a pentagon. Looking at this one's a cylinder, and if I were to slice it this way, cut it open, and look at it, I would see an ellipse, or kind of like an oval. If I sliced it right down the middle, kind of like this, it would look like a circle. This is a cube, and you can see how it's sliced. This is what we're looking at here, which would end up being a rectangle. And this figure, which is a concave figure, we're looking at this tiny little rectangle right here. If it was sliced right down the middle, kind of like down the side like this, you would see a star, but that's not what they're saying that they're doing. The next one says, an architect is designing a contemporary office building in the shape of a pyramid. So we have one base and triangle sides. The building will have 8 sides. What's the shape of the base of the building? It's an octagon, because with 8 sides, that means that the base has to be an octagon, because the octagon tells you that there's 12 triangles on the sides. The next one, it says the figure at the right shows a cube that is intersected by a diagonal plane. So it's very similar to what we talked about with the cross sections. The cross section passes through 3 vertices of the cube, as you can see in the picture. What type of triangle is the shape of the cross section? This one's an equilateral triangle because each side of this triangle is a diagonal of the sides. That's a diagonal of the top side, diagonal of the front side, and diagonal of the side. So it's an equilateral triangle. If the edge length of the cube is 1, what's the length of the line segment? So what they're telling us is if this is 1 and this is 1, what is this? And I redrew that picture here for you. So if you have 1 and 1, we know that that has to be a 45, 45, 90, which means that diagonal is going to be a square root of 2. Last one says, if the edge length of the cube is 4 square root of 2, what is the perimeter of the cross section? Well, again, I gave you a picture here. If both of those are 4 square root of 2, then this diagonal has to be 8, which means, going back here, that means this side is 8, this side is 8, and this side is 8. So you have this triangle, this cross section has 8, 8, and 8, which means it has a perimeter of 24. Here's your homework, and remember, you will have a quiz on this next time I see you on Wednesday. And if you have any questions, I can answer those before the quiz.